Welcome to the IT Global Direction. I am Rorisang Hlahatsi-Baloyi. I'll be your host for today. Edzai, please introduce yourself. Where are you in the world? What do you do? And what's the hot topic for today?
Sure. Thank you, Rorisang. It's a pleasure to be here today. My name is Edzai Conilias Zvobwo, and I'm based in Johannesburg. I work for a small startup where we've got this big forum for maths and data science, where students and professionals can actually go in and ask questions, and then our experts answer them. So now we're actually in a limbo since ChatGPT has come, and we are wondering whether we should just automate the answer. So that's a question that maybe you will find an answer to today. And we also do web analytics and anything to do with data. Basically, we try and help organizations become data-driven, not even just data-driven, to make data-informed decisions, not just thumbsuck their way through life. So basically, that's what I do for a living.
Sounds interesting, Edzai. Edzai, what is data? I mean, we hear a lot of people talking about it, but what is data?
So data, by definition, is just information. It's information that, if analyzed, can be used to make decisions, to give insight into what's happening, what could happen, that is prediction, or even prescription as well. So nowadays, because of the advancement of technology, the chip has become so potent that it now allows us to actually have what is known as multimodal data, where we have video, we have audio data, we have unstructured data, structured, so there's so much data in different modes. So we are swimming in data. And I mean, people from the 60s would be so envious if they knew how much data we have at our disposal.
And Edzai, how is this data changing the world? I know you just mentioned that people in the 60s, but data was there even then. But how is this data now evolving our information technology world today?
I think the biggest thing that happened is that the computer became very powerful. The processors can now process quite a lot of data. We have GPUs and other really big machines that can handle terabytes of data. And also the convergence between statistics and computer science was one of the most seminal things to happen for data, because now people can actually build products beyond just the theoretical analysis, statistical analysis. Now, computer scientists and even other fields, they're coming in with their skills and being able to operationalize that data, those insights, and coming up with products. That's why now you find that we have systems that can recommend at scale. They can even prescribe and guide us. I mean, for example, if a GPS is data-driven, and it's prescribing the best route to move from point A to B. That wouldn't have been possible if there wasn't a merging of computer science and statistics among other subjects as well. So so that's the difference between us and the 60s.
That's really incredible. And what's quite interesting is how data has evolved, and now we're using it to predict the future and do things in the future. And if you were to advise someone that is interested in joining this data evolution, what would you say to them? What do they need to do to prepare themselves to be effective in this data evolution?
I think to start off with a data journey, we have to teach people how to think. For me, that's where I start to say the logical thinking. And the logical thinking, we're taught, most of us, from grade 1, doing mathematics, all the way to physics in high school, into project management, business analysis, software development lifecycle. Because if you look at it, data science is just but a tool among many tools. It's just a manifestation or a mutation, actually, of something that we've known from way back, something that even management consultants even use in thinking about problems and structuring them for organizations. So I'll give you 5 steps that I'll call the skeletal system of problem solving. And there's a mathematician, a Hungarian mathematician, in 1945, he coined it the skeletal system for solving mathematical problems. But this can be extrapolated to any situation in life. So the first thing is that without even talking about data, we first have to understand, say, what is the problem? We need to identify the problem. That's the first and foremost thing. And then when we've identified that there's a problem, right? Then the second step is to understand the problem, to say who is involved, what is involved, when did it happen, what do we have, what's the what's the objective, all those questions, right? After we've understood the question, and if there is element of data, if data can be collected or data exists, then we know that we are able to use data based on our understanding of the problem. Then once we've understood the problem, we devise a plan now to say, okay, since this is, we're going to be taking photos. So this is pictorial data, right? So that means that, and also maybe there's GPS data as well. So maybe a GIS system, right? A geographical information system is the best tool to use to deal with the data. So we say the first step is identify the problem. Second step is understand the problem. Third step is devise a plan, which in mathematics is come up with a formula, which in data science is what method are we going to use? Are we going to use supervised learning? Are we going to use unsupervised learning? Are we using principal components analysis or whichever algorithm? But these are just methods based on our understanding, right? Now, when we've devised a plan, then the fourth step is to carry out the plan, right? So we carry out the plan. And after implementation, then we evaluate. That's where now you come up in data science. That's where they talk about ROC curves. They talk about accuracy, precision, all those other F value, F test, all those things. If in statistics you're talking about, let's see the P value. So at the end of the day, it's problem solving based on principles that we've already known. But in this time around, we're just contextualizing it for data so that we can speak the same language. You get it? So if you look at the machine learning process, right? You get data, you split it into training set and testing set, right? So you run your algorithm, you train it on the training set, and then you see how it performs with what you've held out as the testing thing, right? And you can see, and if it doesn't work, then you can try a different algorithm, or you can try combining the problems. So at the end of the day, it's still the same thinking that we've always done. So if you're coming from a business analysis perspective, again, it's still the same workflow, where you get business requirements, and you know what I mean?
Yeah, no, I understand.
So if you're coming from project management, you are bringing that same thinking. Physics or anthropology, you're bringing the same thinking, which is problem solving. So I think the most fundamental thing that we have to make sure that anyone who wants to go into data is that they follow the scientific method. Because the scientific method is basically those steps, and you just add or subtract or rename steps, but otherwise it's still the same thing that you've always done in project management.
That's incredible, Edzai. When you speak to people, they'll say data people would focus on theory. How do you see data steps that you just given to me being embedded in business processes, where now maybe you have to implement something in a financial service institution or in a government institution? Would you give our viewers an example of how these fundamental steps that you've indicated can easily be embedded in real life businesses, and where we can now see returns on those, where we invest in data. How do you foresee this being embedded?
So in my other life, I've actually taught executives from blue chip companies, and these are non-data people. So it was data science for the non-technical executives, you know. And what came out was that there's a disconnect between the technical team and the business side, where they don't speak the same language. So it's important that the executives at least be conversant of the technical side, or just understand the process. So if somebody, so putting on the hat of a business executive, they should be able to ask the right questions, right? Such that these technical people won't take them for a ride, you know, because they can drown you in jargon and tell you that, and tell you about rock curves and, you know, how the algorithm, you know, I use this binary what instead of logistic regression, and, you know, they can go into detail. But out of all that, the business executive should be able to ask questions. So if there's a framework that both business and technical can actually have and be able to work with, that's common and aligned to the strategy of the company and the goals and a vision and mission of the company, then it's easier for non-technical to talk to technical. So in the course that we had, we didn't go into deep programming and coding and stuff like that. But I can assure you that those graduates that we dealt with, they understand the data science workflow, machine learning workflow. They understand the difference between supervised learning and unsupervised. They understand the types of data, that there's numerical data, there is this. They understand the difference between forecasting, right? Prediction. And they know that using pie charts to predict is wrong, because we taught them what is known as the Gartner levels of maturity, you know, because every organization is at a certain level in terms of maturity from a data science perspective, data analytics, basically. So most companies, I think, especially like here in South Africa, where I am, you'll find that roughly 80 to 90% of companies are on the very basic descriptive statistics. So descriptive statistics, where they just get summary statistics, they get the average, they get a pie chart, a bar graph, and then they actually predict using descriptive statistics. You know, they're not even doing simple cross tabulations or correlations, you know, just to say, okay, this is related to this, you know, that kind of thing. So it's important for business people to be able to speak the language of the technical, and then the technical also have to speak the language of business. In the event that these two sides are disparate and can't speak to each other, then you need a translator in the middle. Then that translator becomes the most important person who understands both sides of the world. You know, so that's how I see a lot of companies doing good in terms of data. I'll give you a case, right? There's a bank in Spain. I don't know if I should say its name. Okay, BBVA. Right. So with BBVA, what they did, because they were considered one of the best in terms of digital transformation. There's actually an MIT case study where they literally taught everyone from the janitor to the CEO. Everybody learned basic data analytics, such that the person on the till, right, knows that when I'm entering these details, it has an effect on the quality of data that's going to come out on the other side, where the data scientist or the actuary has to do work. So just appreciation of the fact that I'm contributing in an enormous way to data science, even if I'm not a data scientist, is the starting point. I think There's a popular saying that says that a janitor was asked when they were doing the moonshot program in the US, trying to go to the moon back in the 60s.
Yeah.
And the guy said, no, I'm not sweeping the corridors. I am actually sending a man to the moon, because without him taking the garbage, the guys wouldn't work optimally. So everybody's in it, and everybody should speak the same language. Okay, that was a mouthful.
No, no, it is. I like how passionate people from the data side of the world are. Hey, I always feel this passion. And it's just a quick one. If now I'm a graduate or I'm changing careers and I'm really interested in joining data or this data world, data and analytics, are there any specific technologies that I need to familiarize myself with?
With technologies, that's the problem, that if you learn a certain technology as opposed to another,
Yeah.
it's not optimal. What you should learn are the basic fundamentals that are transferable between technologies, because I believe that with open source languages, for example, like Python, right?
Yeah.
It's transferable whether you go left or right, or any of the major suppliers in terms of technologies and cloud solutions and stuff like that. You will be conversant, right? So learning the fundamentals and understanding is important, because you'll find that there are a lot of people that are calling themselves data scientists, but they lack, maybe they're coming from a computer science side, and then they lack the stats. So they're busy butchering statistical validity and reliability.
Yeah.
And then there's a crop that's coming in from your stats that are good at stats, but cannot build solutions, So it's important now to emphasize the fact that when you want to get in, look for a mentor who is going to either complement the skills that you have or augment and push you to improve where you are already. You get it? So it's important, because you find that data science is not a one-man show. I mean, that's what we've been sold. And it goes back to the likes of Mark Zuckerberg being shown in a dome, hacking on their own. That doesn't work. That doesn't happen. Data science is a sport team.
Yeah.
Team sport where we have to complement each other. So even if you are not as data literate or as good at coding, try and insert yourself into that data science team with whatever perspective that you have, and then make sure that you learn the other aspects of data science. Because
So you're mentioning that data science person is not a sole player. So can you just expand on it, on how exactly do you foresee data people playing within big organizations?
So, I mean, big organizations are still trying to figure out what the best models are in terms of data, so as to get the most out of the insights that are coming in from data science teams. So you find that some have hubs where they're centralized, and then some believe that every business unit should have its own data science team. So it depends with the industry, it depends with the size of the company, whether a federated approach where you have every business unit having their own data scientists, or having a hub where you have data scientists that service the business units. But obviously, each method has its own pros and cons, because you find that if they are centralized, they might not have enough understanding of the business units to be able to serve them properly. But if you have data scientists in the business units, then there's no central hub where they can exchange ideas and help each other forward, So the data science team, in terms of cohesion, is actually disrupted by them being scattered all over the place. So it's maybe a hybrid method. is what works. But anyway, it always depends with the size and type of organization and the industry that they are in. But anyone wanting to go into data, I believe that we all have what it takes to go into data, because we've got frameworks that we're using already, whether we got them from an MBA or from even chemistry. We've got them. It's just a matter of contextualizing them and learning the jargon of data science, basically.
Edzai, this was a very interesting interview. There's a lot in data that I have discovered. There's a lot in data. You can never say enough about data. So Edzai, thank you so much. You've raised some points that I feel like sharing with our viewers. Let me know if I missed out any big point that you placed on the table today. You mentioned that people that need to go into data, they shouldn't box themselves into a single technology, but they need to look at the patterns that are used in each and every technology to be able to implement using those technologies. So you can't focus on just Python, but you just need to look at the principle that Python is using. You also mentioned the 5 steps that need to be taken when people are embarking in a data-driven strategy or a data-driven project. And you also expanded that data does not only focus on one career or those 5 steps that you mentioned. You said they can be used in project management, they can be used in business analysts and other capabilities within the technology world and beyond. We also indicated that maybe we need to consider hybrid or center of excellence for data, but one approach doesn't always work fully, where you find data being centralized or decentralized. And you also mentioned methodologies and methods that can be used in analyzing the data. And you indicated that the days of using pie charts in analyzing data are not quite there. You need to go deeper into it because data is quite complex. And embedding data into business processes is also very important, because you mentioned in order to better analyze your market or to have better communication between technology and business, you need to understand data, because the only commonality between those two areas is data. Did I miss out any important topic that you mentioned today, Edzai?
No, you captured it very well. Thank you very much. So my parting shot, actually, because I'll say causality implies correlation.
Yes,
Did you hear that?
Yes, but causality is not correlation. It just implies correlation.
Yes.
Yeah.
So, but the converse is not true. So causality implies correlation, but the inverse, the converse is not true. Yeah. Yes. So let's not try and find causes where we've just established correlations. Thank you.
I guess that was it's like data 101. You need to understand really the distinctions between causality and correlation. Thank you so much for joining IT Global Direction, Edzai. This interview has been very informative and really thank you.